Synchronous DRAM. Synchronous DRAM, here there is a memory cell. Okay, this is group of DRAM cells. Okay, here this is row decoder. This will select respective rows. Then this is column decoder. This will select the respective columns. And this consists read write circuits. So read write circuit is used to read the data and write the data. Okay, then it consists latches. So latches is there here, so that whenever you are reading a data, the data will come and is temporarily stored in the latches. Okay, the input to the row decoder data comes from the row address latch. Okay, so first here there are the address line, and there are some lines, the address lines. This is coming from processor. Processor will send the row address initially through these lines. Okay, that the row address comes here, and it is latched only in this row address latch, because at that time processor will activate this CAS bar signal, RAS bar signal, row address selection line signal. That signal will become 0. So that 0 will activate this latch, so that this latch will receive these address, especially that is a row address, and it holds that address in the output side, and that is applied to the row decoder, and that will select the respective row. Again, after some time durations, 2-3 clock cycles, so these address lines are used by the processor, or else I can say that processor will send the column address through the same address lines. That column address will propagate, or it will flow towards this column address counter, because and it is received by this latch. Okay, it consists a latch and as well as a register. So because at the time processor will activate the column address selection signal, this is bar here, that's the reason it is, this signal is becoming 0. This low signals, column address selection signal, will activate this circuit, so that it will receive this column address here, and it will hold that, and that is given to this unit. And this is a column address counter. Initially, right now I will tell you that this column address, whatever it is received, is given to the column decoder, and it will activate the appropriate lines to select the appropriate column of this memory. Okay, now required column and address is selected, and if okay, and if it is a data write operation, data will flow here in this way, and it goes to data input register, and it is loaded here. And if it is a data read operation, the data is taken and it is stored in a latches initially, and from latches it is transferred to this register, and then finally to output devices. So here we are saying clock because it is synchronized. Okay, clock is very necessary here. And this is a row address selection signal. This is column address selection signals. Read write signal. Whenever processor is reading a data, this signal will become high. Whenever processor is writing on memory, this signal becomes 0. This is chip selection. So whenever processor is accessing this particular memory devices, so chip selection should be 0. Okay. So synchronous